subset. So let us see the topic in the subset now. For example, set A and set B. Set A and set B I am taking now. Set A is having some elements 5, 7, 11, 13. So there are 4 elements in set A. And in set B, 5, 7, 9, 11 and 13. So if you observe here, what we can call it as subset. If A and B are two sets, okay, A and B are two sets given in such way that every element of A is in B, then we can take A is a subset of B. So every element of set A is in set B. So 5 is element is in set B, and 7 is in element of A and is in set B, and 11 and 13 also is in B. So some extra elements are there, but every element of A is in set B. Then we can take A is a subset of B. So we'll denote that is B. Now this is subset of symbol. So we have to keep like this. Fine. So this is a subset symbol. A is subset of B. And sometimes every element of A is in B, and if it's not there means there is a not subset. So A is a subset or equal, and we can write A is subset or equal to B also, subset or equal, but it is subset is that implies, so we can write, for example, X is belongs to A and that is X belongs to B also. So if A is a subset of B, we say that B is a superset of A, right? Then B is superset of A, we can say, because A is a subset of B means B is a superset of A. So we can write like this is superset. If there exists even a single element in A which is not in B, then A is not a subset of B. And we write, so A is not subset of B. So with some more examples I'll explain it clearly. So for example, let A is a set X such that X is prime. X is the prime and condition is 3 less than X less than 15. That means all the prime numbers between 3 and 15. That is set A. Okay, now set B. Set B is a condition is X such that X is odd number, X is odd, X belongs to natural number. You have to describe first, then only we can say X3 is less than X less than 15. Now these two are in set builder form. Now if you write in a roster form, you will get clearly. So A is the set. Now X is prime number but from 3 to 15. Okay, after 3 the prime numbers are 5, 7, 11 and 13. This is set A. And set B, if we write, is X is odd number but between 3 and 15 all the odd numbers, that is 5, 7, 9, 11, 13. Okay, observe now 5, 7, 11, 13, these 4 elements are in set B. So clearly we write set A is subset of B and set B is the super subset of A. Okay, one is a subset and one is superset. So superset. So B is a superset of A and A is the subset of B. One more example. For example, So I'm taking let C is a set X such that X is equals to 3n and n is belongs to natural number. Set D is X such that X is equal to 6n and n is belongs to natural number. Okay, these two are infinite sets only. Even though we can say we convert into roster form. So set C is equals to 3n. N is a natural number. If n is 1, first number 3 will come. If n is 2, in the place of n is 2, 2 3 is 1, 6. Nothing but they are all multiples of 3. 9, 12, 15 and so on. Now set D is 6n. So multiples of 6. 6, 12, 18 and so on. So every element of D is in C. Now if you observe, 6 is here and 18. So after 15 they can get 18 also, because if it is multiple of 6 then that is a multiple of 3 also, 12. So all the elements of D are in C. So we can write D is a subset of C and C is a superset of D, right? So we can write like this. Okay, some important properties I'll show you in this subsets. So important results on subsets. Okay. So if you observe, every set is a subset of itself, because every element is element of itself again. So every set is a subset of itself. Fine. So we can write it is, now A is a subset of A itself, otherwise B is a subset of B and C is a subset of C, so on. Next, every empty set is a subset of every set. Every empty set is a subset of every set again, because the set is already empty. So that is we can denote empty set is null, that is subset of A or subset of B, like anything you can take. Empty set is subset of B, etc. If A is subset of B, third property, and B is a subset of C, then we can write A is a subset of C also. And one more rule, fourth rule, if A is subset of B and B is a subset of A, then both are equal. So A is equals to B. If both are subset for each other, then both are equal. Similarly, if A is equals to B, then A is subset of B and B is subset of A. So vice versa, both you can write. If A contains n elements, if set A has contains n elements, if there are n elements, then there are 2 to the power n subsets. So if there are n elements, 2 power n subsets we can make. So I'll give some more clarity about the sixth point. So for example, A is a set having elements 1, 2, 3. So number of subsets of A. So number of subsets of set A is equals to 2 power 3 because there are 3 elements. 2 power 3 is 8. So there are 8 subsets we can write for A. So I'll write here. So 1 is a, if we take 1 is one set, and we can take 2 because 2 is a, if we treat 2 is a set, 2 is a subset of A, and only 3 and 1 comma 2 is one set, is a subset of A, and 2 comma 3 and 1 comma 3. Again, first point we have seen every set is a subset of itself. So 1, 2, 3, and null set is also subset of every set. That's what null. So finally 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible subsets are there according to the number of elements we can say. So formula is 2 to the power n. 2 to the power n this is. So 2 power n is the formula to find out number of subsets, number of possible subsets from any set. Now we'll see the power set